So today what we're going to do is we're going to be comparing different types of relationships. We've been talking about exponential relationships. We're going to compare them to quadratic relationships that we did in the last unit, as well as some linear relationships, which is a concept that you guys looked at back in grade 9 and grade 10. And so before we even begin with that, we'll do some warm-up activities. We've been talking about different exponent laws, and so we'll go through and we're going to write each one of uh, these problems as or answer it rather as a single positive power, okay? And then we're going to evaluate it. So we don't want to have any decimals whatsoever. Okay? So again, exponent laws only apply when you have powers with the same base. So here we've got on the left-hand side, we've got powers with the same base. The base is 2. They're multiplied. So this is the same as saying 2 times 5 plus 3, which is going to equal 2 to the exponent 8. And then we're going to evaluate what 2 to the exponent 8 is. So 2 to the exponent 8 is going to give me 256. If I go to the next one over here in the middle, I've got powers with the same base. Base is 3. So because they're being divided, I subtract the exponents. So 4 minus 2, that's going to equal 3 to the exponent 2. And I can now evaluate that as equaling 9. We're here again have powers with the same base. In this case, my base rather is -2, and I've got a -5 plus 3 because it's being multiplied. So I end up getting -2 to the exponent -2, but I have to write this as a power with a positive exponent. So because I have a negative exponent, I need to flip the base. And I need to then make the exponent positive. And then, so what I'm going to do is actually apply the exponent to both. So 1 squared is 1, and -2 squared is +4. So my final answer there is going to be +4. If I continue to look on, here I've got halves. So again, powers with the same base. In this case, the base is 1/2. So my exponent is going to be 5 plus -8. So that's going to result in 1/2 to the exponent. So 5 plus -8 gives me the exponent -3. I don't want to have a negative exponent, so that means I need to flip the base. So the 2 goes on top, the 1 goes on the bottom, and the exponent then becomes positive. So that becomes +8. In the middle, we've got 33. So we've got a power raised to an exponent. So the power is 33 to the exponent 27, and that's being raised to the exponent 0. So I have to multiply those exponents together. So that gives me 33 times 27, or to the exponent 27 times 0. So that's the same as 33 to the exponent 0, which is the same as 1. Okay, because any number raised to the exponent 1, or raised to the exponent 0 rather, is 1. And then the last form of question, it combines multiple exponent laws together. So I'm going to deal with everything on the top and then everything on the bottom. So again, all 3 powers have the same base. I've got a multiplication piece, and then I also have a power raised to an exponent. So on the top, I've got multiplication, so 9 plus 22. And then on the bottom, I've got a power raised to an exponent, so that's 5 times 5. So that means that I'm going to end up with 2 to the exponent 31 on the top of the fraction, and 2 to the exponent 25 on the top of the fraction, or sorry, on the bottom of the fraction. So because it's now division, I subtract the exponents. So another way to write this would be 2 to the 31 divided by 2 to the 25. Okay, that's just another way of writing that particular exponent. So 2 to the 31 divided by 2 to the 25. Okay. And so because we're dividing it, we end up subtracting the exponent. So that ends up giving us 2 to the exponent 6, and 2 to the exponent 6 gives us a total of 64. So that's our warm-up activity, just going over the exponent laws again.